First step, do our ref so we know what x equals, y equals, and z equals, and then we're going to show our work. All right, I look at this and I want to eliminate the same variable by using 1 and 2 and 2 and 3. I only see one variable that's naked in it. That's an x in the third equation, right? If I make that equation 2, it'll make it easier on me. Do you have to do that? No. But would it be easier? Yes. So I'm going to rewrite it as 2x plus 3y plus 4z equals 2. Then I'm going to put that x minus 5y minus 2z equals negative 4. And then I'm going to put the 5x down here.
And why are you doing it like this again?
I'll show you in a minute, because when you're eliminating the x, it's easier. You don't have to multiply two equations by something, okay?
Right.
So now I'm going to use 1 and 2. And we're going to eliminate something. Well, it makes sense to eliminate the x. And we're going to do that by multiplying the second equation by negative 2. Does everybody see that?
Yeah.
And now we're going to have 2x plus 3y plus 4z equals 2. And negative 2x plus 10y plus 4z equals 8. So now I'm going to add those two equations, and like predicted, the x's bite the dust, and we have 13y plus 8z equals 10. And that is my first equation. We're going to leave it there like you leave the turkey on the side of the cabinet while you're making the gravy, okay? We're just going to leave him there. Now we're going to deal with the second two. Well, the second two, we're going to do these two. In order to eliminate the x, we need to multiply that second one by negative 5, because then it'll be a negative 5x and a 5x. So we're going to do that over here, and we have negative 5x plus 25y plus 10z equals 20, and then the bottom one, 5x minus 2y plus 3z equals 0, and when we add those together, the x's bite the dust, and we get 23y plus 13z equals 20. So now we have the 13y, 8z, and 10. I'm going to put the 23y, except I'm going to do it right. 23y plus 13z equals 20. And I always look to see which one has the smallest number, since they're both going to be annoying to eliminate, right? And it's the z's have the smallest numbers. So let's just eliminate the z's. So I'm going to multiply the up guy by negative 13 and the bottom guy by 8. You can do positive 13 and negative 8. They'll work both ways. So now I'm going to use my calculator. And negative 13 times 13 is negative 169y. Negative 13 times 8 is negative 104z and equals negative 130. Everybody see that?
Yeah.
And then downstairs you have 8 times 23 is 184y minus 8 times 13, which is 104, positive 104z equals 160. Okay? So when I add these together, the z's as predicted bite the dust, and we have 184 minus 169 is 15y, this thing's getting prettier by the minute, equals 30. So y equals 2. And I go up here and I go, oh my gosh, I'm good. Now I pick one of these two equations and plug in that y so I can find z. And I have 13 times 2 plus 8z equals 10. 26 plus 8z equals 10. 8z equals negative 16. Z equals negative 2. And again, did it. So now I have y and z. I go to the original equation up here and pick one of those three equations, plug in the y and the z to find the x. So I have x minus 5 times 2 minus 2 times negative 2 equals negative 4, right? I'm running out of space here. So we have negative 4 equals x, and that's going to be a minus 10 plus 4. So negative 4 equals x minus 6. Add 6 to both sides, and I get 2 equals x. We got all three of them correct, and you've shown your work. Okay, now the matrix here is a little bit more difficult because you've got to know your alphabet. So when you put P, Q, and R in order, it's P, Q, and R, right? A, B, C, D, F, G, H, whatever, P, Q, R. All right, so they're in order. So we're going to make sure we put our matrix correctly because you can make a big mistake here. We have 1 P, we have 0 Q's in that first equation, 4 R's, and then negative 7. You see why I put a 0 there? In the next one I have 1 P, I have negative 3 Q's, 0 R's, and negative 8. And in the third one I have 0 P's, and I have 1 Q, 1 R, and a 1. So I see that the last equation, and this is not the only way to do it, but I see that the last equation has a Q and an R. And I see that the first two equations have naked P's, right? If I eliminate the P's on the first two equations, I'm going to end up with Q's and R's in that equation. So let's do that by changing all these signs, multiplying it by negative 1 basically, right? And then when I add those two first equations together, I get the P's bite the dust, which is what I want, and I get 7Q. No, I don't.
You get 1.
Yeah. When you add those two together, the P's bite the dust, and you're going to have 3Q plus 4R equals 1. Do you see it? Because you can't add Q's and R's, so you have to keep them separate. So now I have a system of equation with Q's and R's in it. And we need to eliminate one of them and add those together and find the Q and R, and then I can just put those in one of the equations for P and find P. Okay? So this is a little bit different. Every equation in the system has to play. So we've already used the first two, and now we're going to add this one, and we're going to eliminate the Q or the R. We can eliminate either one, and then find Q and R. So here, if I multiply this one by negative 3, right, I get negative 3Q minus 3R equals negative 3. Q's bite the dust. I have R equals negative 2. Looks like I got a winner. Okay? Now I put that in. I have Q plus negative 2 equals 1. Add 2 to the other side, and I have Q equals 3.
Wait, could you do?
So Q equals 3 looks like a slam dunk. And now I just have to find the P. So I go back to the original equation, P plus 4R equals negative 7. I know R, I don't really need Q for that one. So P plus 4 times negative 2 equals negative 7. P equals P minus 8 equals negative 7. Add 8 to both sides, P equals 1. Got that one too. So I found all three by using elimination.